Hello everyone, welcome to my channel. In this video, we are going to break down the UGC NET Computer Science previous paper of the year 2007 December paper 2. There are 50 questions in this paper. We will cover the first 25 questions in this part, this part 1, and the remaining 25 questions in the part 2. I will explain complex concepts in simple terms and provide tips and tricks to help you ace the exam. So, whether you are a beginner or an experienced one, this video is for you. So let's start the video. A box contains 6 red balls and 4 green balls. So a box will contain 6 red balls and 4 green balls. So 4 balls are selected at random from this box. So what is the probability that 2 of the selected balls are red and 2 are green? So we are selecting 4 balls randomly from the given box. Okay. So among the 4 balls, so the selected balls will be 2 are red and 2 are green. So 2 are red and 2 are green. Okay. So first of all, let us check so what is the total number of balls here? So total number of balls are 10. And from the total number of 10 balls, so 6 plus 4 is 10, right? So 6 plus 4 is 10. So from the 10 balls, we are selecting 4 balls here. So 10, 3, 4. Right. So from 6 red balls, the drawn balls will be 2 red balls. So from 6 balls, red balls, 2 we are drawing here. And 2. So from 4 green balls, we are drawing 2 green balls. 4, 3, 2. So if you solve this one, that is 6C2 is 15 into 4C2. That is 4C2. That is 6 by 10C4 is 210. I hope that you all know how to solve the permutations and combinations, right? So if you solve this one, so you will get the 15 into 6 is 90 by 210. That is 3, 7. This is 721. So 3 by 7 is the answer. Option A is the correct. Next. The number of edges in a complete graph with n vertices is equal to. So we know that a complete graph is a graph where each vertex is connected with every other vertex here. So it is an undirected graph where each edge is connected with each vertex is covered with another vertex. So here the given graph is a complete graph. So here every vertex is connected with another vertex. Okay. So normally the complete graph formula is n into n minus 1 by 2. So let us see. So it is solving the given complete graph or not. So how do we check whether the graph is complete? So it is an undirected graph. So every vertex will be connected to every other vertex. So n into n minus 1 by 2 is the formula here. So we know that there are 4 vertices here. So let us substitute this in the formula 4 into 4 minus 1 by 2. So 4 into 3 by 2, that is 12 by 2. That means answer is 6. So here the number of edges in complete graph with n vertices is equals to 6, right? So we have 6 edges here connecting the 4 vertices. 1, 2, 3, 4, 5, 6. Right. So option B is the correct one. Next, a context-free grammar is. A context-free grammar is a type 2 grammar that generates the context-free language. So from the given diagram here, so here type 0 supports the unrestricted grammar, so recognized by Turing motion, and type 1 supports the context-sensitive grammar accepted by the linear bounded automata, and type 2 is a context-free grammar accepted by pushdown automata. So type 2 is the correct one. Next. Let E is a function from b power m to b power n is a group code. The minimum distance of E is equal to. Actually, this answer for the given question is unknown. So let us go to the next question. Consider a Moore machine M whose diagram is given as. So here given the deterministic finite automata here. So this is a Moore machine. So in the Moore machine, so the main importance is given for the state, the current state, but not for the output. Right. So here given the DFA here, so it will generate the regular expression, that is so for starting from the S0, that is the starting state, and S2 is the final state here. So S0 here, so A star B and A star B into A plus B whole star. So this is the regular expression drawn from the Moore machine. Okay. So here this expression has a set of strings that contain at least two B's here. In the given DFA, it can be clearly noticed that the minimum string that is accepted by Moore machine M is BB and BB. So the language can contain 0 or more number of A's and 2 or more number of B's. Okay. So here option A is the correct one. 2 or more number of B's. A well-formed formula that is equivalent to x implies y. So we can write the x implies y as negation y implies x. So option B is the correct one. So how can we negation y implies negation x. So how do we consider here this one? So option C is the correct one. So how can we derive this one? So we know that x implies y. X implies y. So we can write the x implies y as negation x or y. So we can write the y here as a negation of negation y. So we can determine this y variable with the two negations, right? So negation x or negation of negation y. Okay. So that means we can write it in a reverse manner, right? So negation of negation y or negation x. So we can write this form as a, so it is in the form of P implies Q, that is negation P or Q form, right? So here negation y or negation x. So we are considering this one as a particular variable. So next we can write that as negation y implies negation x. Right. So we can write the given well-formed formula like this one. So it will represent the contrapositive of the x implies y. So option C is the correct one. Simplified form of Boolean expression xy plus negation xz and yz is. So we can write the given expression here by using the consensus theorem. So we are considering yz into 1 here, right? So here there is nothing, that's why we are considering into 1. So now we will solve this given expression xy plus x dash z plus, we can write the 1 as x plus x dash into yz. So if we open this parenthesis here, so xy plus x dash z plus xyz plus x dash yz. So now if we take the these two variables, common variables, xy plus xyz and x dash z plus x dash yz. So here x dash z is common and here xy is common. So xy into z plus 1 and x dash z into y plus 1. So we know that z plus 1 is anything plus 1 is 1. So here xy into 1 plus x dash z into 1. Okay. So here the correct option is option A, xy plus x dash z. So this is a simplified form of the given Boolean expression. So you can solve the same thing with using the kernel map also. So option A is the correct one. So in order to build a mod 18 counter, the minimum number of flip-flops needed is equal to. So here given that mod 18 counter. So the number of flip-flops required for designing a mod n counter is, we need 2 power n, right? So the number of flip-flops required for designing a mod n counter uh, can be obtained by using this formula. So the number of flip-flops must be less than or equal to 2 times the n, or it must be greater than or equal to 2 power n minus 1. Okay. Or we can write the simplified version of this formula as log n base 2. So here what is the log n here? So log n is the mod 18 counter. Right. So mod n is the 18 counter. So log 18 base 2. So log 18 base 2. That is the, so log 18 base 2 is 4.17. That is approximately equals to 5. So for mod 18 counter, required number of flip-flops are 5. Option C is the correct one. The dual of the switching function f equals to x plus yz is given by. So duals of Boolean expression are generated by replacing the and with or and or with and. And here we are not replacing the variables here. We are not replacing the variable with its complement. Just we are changing the and as or and or as and. Okay. So from given expression x plus yz, so x, so addition will be replaced with product. So x into y, y into z, right? So it will be replaced with addition. So we are replacing and with and or with and. So x into y plus z. So this is the dual of the function x plus yz. So here option D is the correct one. Next. Among the logical families DTL, TTL, ECL and CMOS, the family with the least power dissipation is. The least power dissipation is having the CMOS. CMOS dissipates less power than NMOS logic circuits because CMOS dissipates power only when switching. So option A is the correct one. What cannot replace question mark? What cannot replace question mark in the following sequence to print all odd numbers less than 100? So here they have mentioned what cannot replace. So which option cannot be placed in the for loop from the given options to print all odd numbers less than 100. So here the loop is designed to print all odd numbers less than 100. That is it. We have to print the numbers from 1 to 100. The loop starts with I equals to 1 and increments by 2 in each iteration. So I plus 2. The loop condition should ensure that the loop terminates when I becomes 101 or greater. Okay. So here for every increment the number will increment by 2. That means 1 means 3, 7, 9, and for similarly for 100 it will be like, so before coming to 100, so 97, 99 and 100. Right. For every iteration it is incrementing by 2. Okay. So here the option B is the, this condition is the answer. Option D is the correct answer. Because we cannot replace I less than or equals to 101 here. If we replace this one, then it will print the values 1 to 101 here. But we need to print the values less than 100. That is 1 to 99 only we have to print. Okay. So when I becomes 101, the loop will terminate and no further iterations will occur. So it will print up to the 101 value. So that's why option B cannot be placed in the formula. Option B is the correct answer. Next, consider the following linked list here. Given linked list. Which of the following piece of code will insert the node pointed to by Q at the end of the list? So for the given list, so which of the given options will insert the Q to the end of the list? So that we have to find out here. So first, the loop starts by setting P to the head of the list. So for each and every iteration here, P is equals to list. That means the loop starts by setting P to the head of the list. So that is P to the head of the list. Okay. So next, first we will check the option A. So P not equals to none. So here P not equals to none, but P is having certain value, right? So that's why we will exclude this option. And in the option B also P not equals to none, but P is having some value, right? So option B is also not correct. Next, so we'll check the option C here. So P equals to list. So we are assigning the P to the head of the list and the P as a pointer to the head of the list. Next, P implies next is not equals to null. So here the next value of P is not equals to null only, right? Okay. So then we will traverse the, so if this condition follows, we will move to the next. That is, we will move to the next node in the list and assign P equals to Q. So P equals to Q means the pointer P will move to the Q here. So it is also not applicable. We have to insert the node Q to the list here. So this option is not satisfiable. So next check the option D here. Okay. So here the loop starts by setting P to the list. Okay. To the head of the list. The loop continues as long as P implies next not equals to null, meaning P is not pointing to the last node. So this the pointer P will move to the next node until the next value is not equals to null. Okay. Here next is not equals to null. We have some value, right? So we will move the pointer P to the next value until the next value is not equals to null. So when we reach the end of the list, so here the P next value is null. Okay. So here the condition will become false. So here the P the next value is null and the condition becomes false. So the loop will exit and P is pointing to the last node here. The line P implies next equals to Q sets the next pointer of the last node to point to the node Q here, effectively inserting Q at the end of the list. Okay, so P implies next equals to Q means so the next pointer will point to the Q here. So the correct option here for inserting the node to the end of the list is option D. Next, which of the following is a valid C code to print character A to C? So from the given options, which option is correct for switch case? We know that in a switch case, we have a switch followed by some expression. Next, each case followed by some value and then break statement, semicolon. Right. So it will follow that syntax. So here in the option A given here, the 13th, the option A, so this is not valid. The option A is not valid because the case statement should be followed by a constant expression, not an assignment. So here case A is, we are assigning some value for the case A. Okay. So here there should not be any equals to operator. There must be a colon operator. So that's why the option A is wrong. Next we will check the option B. So this is also not valid because the case statement can only compare the expression with a single value. So here there is a range of comparison. So A less than or equals to X less than or equal to C, which is not allowed. So that's why this is also not valid expression. Next we will check the option C here. So in the option C, so this is valid and it is following the correct syntax of the switch statement. So switch statement followed by case A colon particular statement. So case value and break statement. Case value and break statement. So this is following the correct syntax of the switch statement. And option D is also not valid. So therefore, so here option D is also having the same syntax as the option A. So which is assigning some value to case A. Which is assigning some value to case A. So that's why option C is the correct answer. Next, which of the following is not true in C++? So which of the following options is not true in the case of the C++ language? So private elements of a base class are not accessible by members of derived class. Protected elements of base class are not accessible by members of its derived class, and so on. So we'll solve this problem here. So we have a simple table of the accessibility. So whether the base class can be accessed by derived class or not in public, private and protected members. Okay. So we can derive the public members from base class in the case of the public and protected, but it is not possible in the private. So the members in the base class can access the data here, but from derived class it cannot access the data. Okay. So here option B is the correct one. Protected elements. Which of the following is not true here, right? That means which is false. Protected elements of a base class are not accessible by members of its derived class, which is false. So it can be accessed by the members of the derived class, so which is mentioned here. Okay. So that's why option B is the correct answer. Which of the following is true of a constructor function in C++? So first of all, in order to solve this question, we must know the properties of the constructor. A constructor function is a special member function whose name is same as the class name. So these are the properties of the constructors. So first one is the automatic invocation. A constructor is automatically called when an object of the class is created and it has the same name as the class. So whatever the name that we are giving the class name, it will be the constructor name. And there is no return type in the constructor, and the constructors can be overloaded, and constructors cannot be called explicitly. So they are automatically invoked when an object is created, and it cannot be inherited. And there are three types of constructors, that is default, parameterized and copy constructors. So if you see the options here, so a class must have at least one constructor, so which is wrong option. A constructor is a unique function which cannot be overloaded, but here given it can be overloaded. So option D is also wrong. A construction function must be invoked with the object name, but here it is automatically invoked here, right? So that's why option C is also wrong. And a construction function is automatically invoked when an object is created. So this one is correct. Okay, so option D is correct answer. Next, a primary key for an entity is. A primary key for an entity is a candidate key. A primary key must satisfy two properties, that is, a set of attributes included in the key must uniquely identify every other attribute, and it should not be null. So by this definition, option B and C can be eliminated. Out of a set of candidate keys, we choose one of the key and call it primary key. Okay, so option A is the correct one. That is candidate key. Next, what is the aggregate functions in SQL? So aggregate functions means the minimum, maximum, sum, count, average. So these are the aggregate functions. So option B is the correct one. Next, if a relation is in 2NF and 3NF forms, then so what will happen? So in the case of 2NF, so there should not be any partial dependency, and it must be in first normal form, right? 2NF must be in first normal form, and there should not be any partial dependency. Whereas the 3NF must be in 2NF form, and it should not have any transitive dependencies. So first of all, what is a partial dependency and transitive dependency? Okay. So partial dependency means a non-prime attribute depends on only a part of a candidate key. Okay. So there should not be any partial dependency in the second normal form, and there should not be any transitive dependency in the third normal form. That means there should not be any condition such that a non-prime attribute depends on another non-prime attribute. Okay. So option A is the correct option. Okay. So this is in 2NF and 3NF only when no non-prime attribute is functionally dependent on other non-prime attributes. Next, the end of a SQL command is denoted by. The end of the SQL command is denoted by semicolon. Next, consider the query select student name from students where class name equals to select class name from students where math marks equals to 100. What will be the output for the given query? So here in the given query, the inner query, that is this inner query, it will retrieve the name of the class in which at least has 100 marks in maths, 100 marks in the mathematics. And the outer query will display the student names of the classes retrieved by the inner query. So here the option B is the correct answer. The names of all students of all class in which at least one student has 100 marks in maths. So option B is the correct one. Consider a rooted tree in which every node has at least 3 children. What is the minimum number of nodes at level I greater than 0 of the tree? Assume that root is at level 0. So we have to consider a tree here in which every node has at least 3 children. That means minimum the node is having 3 children. So 1, 2 and 3. So 3 children are there. So at which level it is? In level 0 there is a root node. And what are the number of nodes here? So 1 node is there. And at level 1 we have 3 nodes, right? Suppose every node is having minimum 3 children here. So we are considering minimum 3 children here for every node. So for every node we are considering 3 children here. Minimum 3 children. So maximum many children can be there. So minimum 3 children we are considering. So here what are the number of nodes at level 2? At level 2 we have totally 9 nodes. So if you calculate here at level 0 we have 1 node, and level 1 we have 3 nodes, and level 2 we have 9 nodes. So that means, so here 3 power 0, right? So 3 power 0 is 1. So here we will write, so 3 power 0 is 1 and 3 power 1 is 3. right? And at level 2, so 3 square, it is having 9 nodes. And suppose 3 cubed, at level 3 we have 27 nodes. At level 4 we have 81 nodes, and this will go so on. Okay, so the answer is 3 power I. I is the level, right? So 3 power I is the correct answer, that is option B. Next. Which of the following data structure is used to implement recursion? So we use the stacks to implement the recursion. Why? Because stack follows the last in first out principle, whereas the queue works in first out principle. Recursion is a technique of solving any problem by calling same function again and again until some breaking condition where recursion stops and it starts calculating the solution from there on. In order to calculate the final solution, we need all the number in same order. That is last in first out data structure. Hence, stack is the best choice for the recursion. Option B is the correct answer. Next. The height of a binary tree with n nodes in the worst case is. So height of a binary tree with n nodes is big O of n. Next one. An example of a file extension is. Here from the given one, the file extension MP3 is the extension. So text is not correct one, because you can represent the text files, that is the notepad files, with a .txt, not .text. And option B, the pict. So pict is also not valid file extension, right? So file extension means so the extension followed by the file name, it denotes the type of the file. So for text files, that is for notepad type of files, it is .txt, and .pict is not there. So for pictures, so we'll represent .image, .img, like that. And MP3, so we use the MP3 for audio files, .mp3. Okay. So these are the correct ones. So option C is the correct answer. The performance of a file system depends upon the cache hit rate. If it takes 1 millisecond to satisfy a request from the cache, but 10 milliseconds to satisfy a request if a disk read is needed, then the mean time in milliseconds required for a hit rate h is given by. So here the hit rate is 1 millisecond and miss rate is 10 milliseconds. So we need to find out the mean time required for a hit rate given by. So here the cache hit rate is h. And the time taken, the cache hit is 1 millisecond and cache miss. So if there is a miss in cache, that is if the CPU has a miss in the cache memory, that means if the data is not available in the cache memory, then it will search the main memory, right? It will search the main memory, the CPU will search the main memory. So if the data is available in cache memory, then it is called as a cache hit. And if it is not available in cache memory, then it is called as a miss. Okay. So here the cache hit is 1 millisecond and the cache miss rate and the time taken to fetch the data from main memory is 10 milliseconds. So here the cache miss rate is 1 minus h. So we have the formula to calculate the mean time calculation, that is T equals to probability of hit into time for hit and the probability of miss into time for miss. So probability of hit is, we are considering it as a h and the probability of miss as 1 minus h. Okay. And time for hit is 1 millisecond and time for cache miss is 10 milliseconds. So if we substitute the values in the given formula, we will get the answer, that is T equals to 10 minus 9h. Okay, so here this is the correct answer here mentioned. If we simplify this option, then we will get the t equals to 10 minus 9h. So option B is the correct answer. So these are the first 25 questions in the part 1. So we'll discuss the remaining 25 questions in the part 2. Thanks for watching the video.